Mockles, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 68 for the week of April 21st, 2021. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, April 21st, the moon is gibbous, between half full and full, and up for most of the night, setting a couple of hours before morning twilight. The moon is full on April 27th, 0330 Universal Time, which for some of us will be on the evening of Monday, April 26th. By next Tuesday, April 27th, the moon will still be bright and up all night. For this week's full moon, on the night of April 26-27, the moon will be closer to us than normal at 222,000 miles, which is 357,000 kilometers. Actually, 12 hours before full moon, it reaches that distance, but this is the closest full moon of the year. Some people call this a supermoon, which I think sets expectations far too high. It is about 7% closer than its average distance, but most people do not notice that. Nevertheless, the moon rises at the time the sun sets, so go see for yourself. On April 22nd, 23rd, and 24th, the planets Venus, Mercury, and Uranus pass each other. Actually, Mercury passes by Uranus and Venus. They will all be within 7 degrees of the sun in the evening sky and not easily visible. The LUWD meteor shower is occurring this week, with a peak being Thursday morning, April 22nd. The radiant is a constellation Lyra, which rises around 10 p.m. However, the moon will be in the sky for most of the night. And your best bet for this meteor shower is to get out there after moonset, which will be when the radiant is high in the sky. This will be 1 or 2 hours before morning twilight begins. You might see 5 to 10 meteors per hour. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, April 21st, through Tuesday, April 27th. It all depends upon your location. This week we have 7 zones. All you need to know is your latitude. North of 50 degrees north, you will not be able to see the International Space Station this week. It simply will not be in your sky. From 40 to 50 degrees north, it will be in your morning sky beginning later this week. From 22 to 40 degrees north, and that's many of you, the ISS will be in your morning sky for just about the whole week. So get up early if you want to see the International Space Station. From 10 degrees to 22 degrees north, the ISS will be in your morning sky, but only for the first few days of this week. As we head further south from 31 degrees south to 10 degrees north, the ISS will not be visible this week. From 42 degrees south to 31 degrees south, that's parts of Australia, New Zealand, northern New Zealand, and parts of South America, the International Space Station will be in your evening sky, but only for the first few days of the week. Finally, from 42 degrees south to about 60 degrees south, where the temperatures are cooling off, the ISS will be in your evening sky sometimes twice per night. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. Comet C/2020R4 Atlas is moving rapidly through the morning sky, but the bright moon will make this a difficult target this week. Next week, both the comet and the moon will be better placed for observing Comet Atlas, and we'll talk about it more next week. Now for the astro class. 4 weeks ago, I began a series on elementary astronomy for those new to the hobby or for those wanting to learn more basic astronomy knowledge. This week we cover meteor showers. Meteors are shooting stars or bits of rock which enter our atmosphere and burn up due to the heat of friction. You have probably seen them streaking across the sky. On any given evening, you may see a couple or more meteors per hour, and perhaps double that number, 2 to 4 per hour in the morning sky. When a comet comes through the inner solar system, it leaves behind dust and sometimes even bigger stuff, like big dust or small pebbles. Comets might orbit the sun every 5 years or 75 years, and each time they leave behind more and more material along more or less the same path. There are many comets out there and lots of trails of stuff. A few of those trails intersect the Earth's orbit. That is to say, our Earth on its orbit around the sun encounters some of those paths of debris. It's like driving your car down the road and running into a swarm of bugs. It doesn't last forever, but for just a few seconds. So when the Earth meets a comet debris path, we get a meteor shower. If the debris path is narrow, the shower lasts only a day or two. If the debris path is wide, the shower can last several weeks. And when the Earth returns to the same point on the same day the next year, it happens again. Two more things about the meteor stream, the trail of debris. If the comet has been around for a long time, the material is more or less evenly distributed throughout the comet's orbit. Then every year, the meteor shower has about the same strength. But some comets have been on their path for only a few orbits, and the debris is clustered around the comet. For instance, one meteor shower, the LUWD, every mid-November, is good about every 33 years for a year or two when the comet comes back. Secondly, those who study comet orbits and debris streams have gotten very good at predicting which years we will have a good shower and which years we will not have a good shower. I said earlier that comet debris is along more or less the same path every time the comet orbits the sun. Well, the gravity of the planets, especially Jupiter's gravity, can distort the debris trail, move it around a bit, and it can also move the comet around a bit in its orbit. Well, those folks who study comet orbits in the astronomy field called orbital mechanics will sometimes say something like, next Thursday at 1200 hours Universal Time, the Earth will encounter a stream of debris or ribbon that the comet left behind on its passage through the solar system in the year 1478. Yes, the comet has made many trips since then, but that 1478 trail is the exact one we will encounter next Thursday at noon in this hypothetical situation. I am amazed at what those orbital mechanics come up with. they are usually very, very accurate. The term meteor shower might overhype what actually happens during a meteor shower. It isn't like rain falling down. That is a meteor storm. A meteor storm might happen only a few times per century. A meteor shower typically displays only a dozen meteors or so per hour. The minor showers produce only one or fewer meteors per hour. The meteors from a meteor shower all appear to come from the same place in the sky. That is called the radiant, and the meteors move away from that point into all directions. The meteor shower is often named after the constellation in which the meteors appear to come from, or the shower is named after the closest star to that radiant. The Perseid meteor shower, held every mid-August, is named such because the meteors appear to come from the constellation Perseus. How are these meteors counted and compared? Meteor counts are made by amateur astronomers who go out and count meteors that come from the radiant. Those which don't come from the radiant are not part of the shower, and they are called sporadic meteors. Nowadays, radar is used to detect meteors, even faint meteors. This can be done when it's cloudy and during the daytime too. A few meteor showers reach their peak during daylight hours. There are more meteor showers than meets the eye. In my 46 years of continuous comet hunting while looking through the telescope for now 8,800 hours, I've recorded nearly 14,000 meteors, averaging about 8th magnitude. That's fainter than what you can see with the unaided eye. But the range of meteors I've seen through the telescope is from very bright at -4, as bright as Venus, to very faint at magnitude 13. One way to compare meteor shower strength is to calculate what is known as the zenith hourly rate. This is the number of meteors that would be visible if the radiant, the location from which the meteors appear to come from, is directly overhead, and that person observing has dark skies and unobstructed horizons and watches for 1 hour. It is a calculated value, and it allows us to compare meteor showers to each other and to monitor a particular meteor shower to see if it gets stronger or weaker over the decades. When we say that the Perseid meteor shower has a zenith hourly rate, or ZHR, of 100, then that means you'll more than likely see fewer than 100 meteors per hour. That is because for you, the radiant is not directly overhead, and your skies are not as dark as required in the calculation of the ZHR. And how dark is that? Dark enough to see stars to magnitude 6.5, and believe me, those are very faint stars. One factor that brightens the sky is the moon. When the moon is in the sky, fewer meteors are seen. That happens to about 1/3 to 1/2 of the meteor showers each year. When I discuss upcoming meteor showers in these podcasts, I always mention the phase and location of the moon. We hope for a new moon, where it is near the sun and not in the night sky, but in reality, we get all phases of moon for our meteor showers, and each year is different. How do we know which comet is responsible for each meteor shower? For many we do not know, but for some we do, and the connection appears rather certain. In some cases, the comet no longer exists, or it is extinct. In some cases, it might have lost all of its ices and turned into what appears to be an asteroid. There are hundreds of known meteor showers, and new ones are being discovered every year. Most are minor, producing only a couple of meteors per night. These are picked up by sensitive radar. A few are major meteor showers, and it is worth it to know a little bit about each one and memorize the dates for each. The first meteor shower of the year is the quadrantets, or quads, named after the constellation which no longer exists, but the area is just south of the Big Dipper. It peaks on January 3rd or January 4th on some years, depending upon where we are in the leap year cycle. These meteors appear in the morning northern sky, and the peak lasts for only a few hours. The zenith hourly rate, or ZHR, can be as high as 120, which means you may see 20 to 40 meteors per hour. So remember, quads, January 3rd and 4th. The next shower is the one that we have now, the LUWDs. They peak on April 22nd and come from the constellation Lyra. The ZHR is about 20 meteors per hour. LUWDs, April 22nd. In early May, about May 5th, we have the Eta Aquariids, abbreviated ETA. They are best seen in the morning sky, radiating from the star Eta Aquarius. The ZHR for this meteor shower is about 60. These meteors come from Halley's Comet. Eta Aquariids, May 5th. The southern Delta Aquariids peak on July 30th, but can be seen for weeks prior and after. ZHR is 20. So the southern Delta Aquariids, sometimes abbreviated SDA, July 30th. The Perseids is probably the most popular shower, peaking August 12th in the morning sky. The ZHR is 100, meaning you'll see about 30 to 50 per hour. Perseids, August 12th. In October, we have the Orionids, also from Halley's Comet, seen in the morning sky. Now, these peak on October 21st. ZHR is about 20. Orionids, October 21st. November brings us the Leonids, peaking November 18th. This one put on a good show when the comet visits us every 33 years. Presently, the comet is far away, and this gives us a ZHR of only about 15. Leonids, November 18th. The Geminids in the evening sky peak on December 14th. ZHR is 120, and this is one of the most dependable meteor showers of the year. The Geminids, December 14th. Finally, on December 22nd, the Perseids peak. They come from the Little Dipper with a ZHR of 10. Perseids, December 22nd. So there you have it, the major meteor showers brought to you each year. Next week, I'll talk about the moon, all about the moon. To recap the podcast, what's up this coming week? The moon will be full on Monday night, Tuesday morning, April 26, 27. The LUWD meteor shower peaks Thursday, April 22nd, in the morning sky. So you do have to work around the moon. And memorize the dates of the major meteor showers. You have been listening to Looking Up with Don, podcast episode number 68 for April 21st, 2021. I'm Don Machholz. Once again, the related website for this podcast is donmachholz.com. That is spelled DON MACHHOLZ.com, 2 H's. You may reach me at dontheastronomer@gmail.com. Once again, dontheastronomer, that's all one word, @gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's up in the sky, and in our astro class, we'll learn about the moon, Luna, that big bright thing in the nighttime sky. We'll also take a look at a couple objects in our evening sky. All that and more. Thank you for listening. See the sky this week. I'll see you next week.